Hey, welcome back, guys. This is Joe Samo from San Diego, California. Let's give this one a go. In the circle below, A, B, and C, D are chords intersecting at E. AE equals 5, BE is 12, CE is 6. What is length of DE? Give this one a shot on your own, and we'll do it together. All right, this is what's called the intersecting chord theorem. And the bottom line is it goes like this. Let's say you have, that is what's called a chord. So that is a chord. A chord is a straight line that goes from one point in a circle to another point in a circle. And then let's say you have another chord there. What the intersecting chord theorem goes is this, okay? Let's say on this line segment, we're just making up numbers here, not drawing the scale. Let's say from point A to B is 10, and then let's say from B to C is 2, all right? And then let's say here B to D is, let's say 4. Then the intersecting chord theorem says this: the product of this segment AB, which is 10 times BC, so that the product of those two, which is 10 times 2, right? That will equal the product of DB, which is 4, times B to E. All right, we'll call it X, right? So then you'd have 2 times 10, that's 20, equals 4X, divide each side by 4, X equals 5. So then this would be 5. So let's try another example. Okay, this will always work. No matter what, this will work. So let's say from this point to this point is 3, and from here to here is 20, right? And then let's say from here to here is 4, and we want to know what is the distance on that line, right? So the product, we first start with this one. The product of 3 times 20 will equal the product of 4 times X. So we'd have 60 equals 4X, divide each side by 4. So X equals 15. So then this segment from here to here, that portion of the chord would be 15. Okay, so it says here AE is 5. So that means that part there is 5 from there to there. Then it says BE is 12. So from here to there is 12. Then it says CE is 6. And it wants to know what is the length of DE. So we'll call that X from D to E, right? So AE is 5. So the times 12, because that's those two segments, the first segment there and the segment there. That has to equal the product of 6 times X. So 5 times 12 is 60. That equals 6X, divide each side by 6. So X equals 10. So what that means is D to E would have to be 10. The way this will work on a lot of different exams, like geometry exams or algebra exams, SAT, GMAT, GRE, they'll ask a lot of different ways. Here, I'll show you. So let's say you have a circle like that. Wow, dude.
Let's say.
Why do they make it so tough to do that?
Let's say you have a circle like that.
All right, thanks. Drawing a circle is very hard. Thank you, dude. All right, so let's say I have a circle like that. They're going to ask it in a lot of different ways, okay? So an example would be something like this. So let's say this segment of the chord is X, and then from here to here, let's say is 4X. And then let's say from here to there is 9. From here to here is 12. Okay, just making up some numbers here. So the way this would work would go like this. You'd have X times 4X, right, equals 9 times 12, which is 108, right? 108. Okay, so you have X times 4X equals 108. So you'd have 4X squared equals 108. Then you would divide each side by 4. So X squared equals 25, 26, 27. Okay, and then so X would equal the square root of 27, which is 9 times 3. This is a good algebra lesson here. Okay, those match up. So then X would equal 3 times the square root of 3. So then this side would be 3 times the square root of 3, and then this would be 4 times 3 times the square root of 3, which would be 12 times the square root of 3. I assure you it'll come up a lot in your geometry class. If you want to keep rocking and rolling, do this video right here. This guy right here. Do it as fast as you can, and you're going to love doing these. You're going to keep rocking in math.